Welcome to Math Minders Academy. If this is your first time joining our YouTube channel and yet you are yet to subscribe to our channel, we urge you to hit the subscribe button. Click on the notification bell icon so that each time we produce a new video, you'll be among the first to receive it. Share this video, like this video, go to the comment section when you are done watching. Tell us something about this video. Share this. We want to get a feedback from you. And so guys, in our last class, we looked at detailed solution to IGCSE October-November series paper 4.1, where we provided solution to questions 1 and 2, and we are excited to produce volume 2 of this series. And in this volume 2, we are going to look at solution to questions 3 to 6. Hope you are very excited to be with us. We urge you to first go through the question, go to the video description. You'll see a link to download the question paper. You can download the question paper and the My Guide. Walk through questions 3 to 6 and then play this video. You're going to use this video to assess yourself. By so doing, you'll be able to get the maximum benefit. All right, so straight to question number 3. Here we have a table that shows the waiting times for 120 patients at a medical center. And so the table shows us waiting time in minutes and then the frequency. And so we have the intervals given. The first is between 0 to 10 minutes. The second is between 10 minutes to 20 minutes, and we have the frequency 46. And for the first column, we have 2 as the frequency. Then the third column, we have the minutes between 20 to 40, and we have 33 as frequency. And then the fourth column, we have between 40 minutes to 50 minutes, and there are 26. The number there is 26. And that's the number of patients that waited for that long. And then we have 13 patients that waited between 50 minutes to 80 minutes. So here, what are we expected to do? We are required to calculate an estimate of the mean waiting time. An estimate of the mean waiting time. So what we are going to do is to insert another column here. We are going to bring up what we call the mid value, because for us to estimate the mean, we need the mid value. And so here we said we are going to calculate the mid value of the time in minutes. And how do we calculate the mid value? Very simple. Look at the first column. We have the time between 0 and 10. So we add these two numbers, the lower limit and the upper limit. The lower limit is 0, the upper limit is 10. When we add these two numbers together, we divide by 2. So in a very simple explanation, we are finding the mean of the lower limit and the upper limit. So here we add the two numbers and we divide by 2, we get 5. So we write this 5 down. That will be the mid value for the first column. So we do the same thing for the second one. We are going to add 10 and 20 together, and then we'll divide by 2. That gives us 15. We drop this 15. Then for the third column, we are going to add 20 and 40 together, and that gives us 60 over 2. That's 30. We drop this 30. And then the next, we add 40 and 50 together to give us 90, and 90 over 2 is 45. We drop this 45 again. We're going to add 50 and 80 together, and that gives us 130 over 2. That will give us 65. And we put this 65. So we have all the required mid value. So we are going to use this now to estimate the mean waiting time. So how do we estimate it? We multiply the frequency by the mid value. So the frequency 2, we multiply 5, which is the mid value, then plus 46, which is the frequency, multiplied by the mid value 15, plus another frequency 33 multiplied by the mid value 30, plus another frequency 26 multiplied by the mid value 45, and lastly we take another frequency 13 and multiply by the mid value 65. All right, and then we divide by the total number. There are 120 patients. So when we do the numerator, We multiply all those items and then add them together. We get 3,705. And we are going to divide by 120. That gives us 30.875. This will be the estimated mean waiting time. Hope this explanation is clear and simple. Right, good. So let's proceed. Now, for 3B, we have a chart, okay, histogram. So here says that the histogram shows some information about the waiting times at a different medical center. So this is a different medical center, and we have the frequency density, the vertical axis, and then the horizontal axis we have the waiting time in minutes. So here says the total number of patients is 90 and no patient waits for more than 80 minutes. Complete the histogram for the patients that have a waiting time between 10 and 30 minutes. That's that gap after the first bar. You see that for the second class, between 10 minutes and 30 minutes, the histogram is missing, and that's what we are going to get. And so for us to get this, we need to get frequency for this group of patients waiting at another different medical center. So we get a table, so we'll be able to very well calculate the frequencies. Of course, we know the intervals, the time intervals, so we are going to calculate the frequencies. So we say the waiting time, we have the waiting time and we have the frequency. Of course, the waiting times are lined up 0 to 10 for the first part, 10 to 30, that's the missing histogram, and then we have the next histogram. The third one is 30 to 50, that's an interval. Then the last interval is 50 to 80. All right, so now how do we calculate frequency when we are given frequency density? How can we get frequency? So we use the formula here that for us to get frequency, when we know the frequency density, we need to understand first what frequency density is, or how to calculate frequency density. Frequency density equals frequency over class width. So if we make frequency density, of course, given, if you look at the first class, that's between 0 to 10, the frequency density is 1.3. If you look at that bar rises up to 1.3. We are referring to the first bar, the frequency density of the first class. That's the class that has the interval 0 to 10. The frequency density is 1.3, but we do not know the frequency of that class. And what is the width of the class? The width is calculated by finding the difference between the upper limit and the lower limit. The upper limit is 10 and the lower limit is 0. So 10 minus 0 is actually going to be 10. Okay? And so if we cross multiply to make frequency the subject, it gives us 13. And so we enter the 13. Now, the second column, or of course the second class, that's the class that has the interval 10 to 30. We do not know that yet, so we are going to leave it. Let's go to the third one. That's the one that contains an interval between 30 to 50. That bar rises up to 1.5. That's the frequency density. So we write 1.5 equals frequency over 20. How do we get 20? 20 is the class width, and we got this by saying 50, which is the upper limit, minus 30, the lower limit. It gives us 20. And when we cross multiply, making frequency the subject, it gives us 1.5 times 20, which is 30, and that has also been entered into the table. And then we look at the last class. The last class contains interval 50 to 80. All right, and the frequency density is 0.4. If you look at it, it rises up to 0.4. The width of the class is 80 minus 50, which is 30. So we have frequency all over 30 equals 0.4. And when we make frequency the subject, is going to be 30 times 0.4. And that gives us 12. We enter that 12. And then remember also that the total number of patients in that medical center is 90. Meaning that we are going to add up all the frequencies that we have in that table, apart from the one that is missing, and we subtract this total from 90 to get the frequency of that second class that is missing. So we now say 90 minus the sum of these three frequencies, and that gives us 35. So the second class, which has the interval 10 to 30, has frequency 35. So we'll be able to get the frequency density of that class. All we need to do, since we know the width of that class is 30 minus 10, which is 20, and then the frequency is 35. So the frequency density is going to be 35 over 20, and that gives us 1.75. And so what do we do here? Remember, we are asked to complete the histogram for the patient that that is waiting between 10 to 30 minutes. So since we know the frequency density for that particular second class, we are going to draw the bar that will represent that particular patient's waiting time. So we draw that bar, which you can see rising up to 1.75. And so that completes the question. Hope this is very clear. If you have any doubt, you can replay this video over and over until this concept is very well understood. Fine, so that is 3B. We proceed to the next question, and that question is 4A. 4A, we have 4AI. Enzo, Rashid, and Blessy each swim as many lengths of a swimming pool as they can in 15 minutes. The results are shown in the table. And so we have the name and we have the number of lengths. We have Enzo, and Enzo covers the number of lengths covered by Enzo is 11.25, and Rashid covers 18.75, that number of length, and then Blessy covers 20. Now here we are required to find the number of length Enzo swims as a percentage of the total number of length all three people swim. Okay, so we have to get the total. Okay, the total, that will be the total number of length for the three people. And when we get this total, it gives us 50, right? Adding together, we get 50. So, but for Enzo, he swims, the number of length he swims is 11.25. So we are going to write 11.25 over 50 times 100 to convert to percentage. And that gives us 22.5%. So you enter that. And then we'll look at the 4AII. Before this, if you are finding value in our tutorial video and you are yet to subscribe, we urge you to hit the subscribe button, click on the notification bell icon, share this video, like it, give us a thumb up. We want this video to go viral so that other students will have access to it. So please, we want you to support us to make this video go viral. So let's move on to question number 4A. Here we are asked to write the ratio of the number of lengths each person swims in the form Enzo ratio, Rashid ratio, Blessy. So now what we are going to do is to just use E for Enzo, use R for Rashid, use B for Blessy, and we line up this we line up their number of lengths. And then to close up the decimal part, we're going to multiply by 100 because for those numbers that are in decimal, they are given to two decimal places. And so that is to the 100th. And so for us to close up that gap, we multiply by 100. And that will give us, if we multiply through by 100, we are going to get 1,125 for the first, 1,875 for the second, and then 2,000 for the last. Then what we now need to do is to reduce these numbers to the lowest or the simplest form. And for us to reduce to the simplest form, we divide through by 125. And then this comes down to 9 ratio 15 ratio 16. So for question 4AII, the A part, before we proceed to this question, if you are yet to subscribe to our channel, we urge you to hit the subscribe button, click on the notification bell icon so that each time we produce a new video, you'll be among the first to get it. go to the comment section and tell us something about this video. Share this video, give us a thumb up. So we move on to question 4A III. The A part of that question says that each length of the pool is 25 meters. Work out Blaze's average swimming speed for the 15 minutes. Give your answer in meters per second. And so here we said that the Blaze total length equals 20 times 25. All right, 20 is the number of length. Then we are told that each length of the pool is 25 meters. So the total length, or the total distance is going to be 20 times 25, which gives us 500 meters. Okay, when we convert 15 minutes, that's the time taken to cover this distance. When we convert the 15 minutes to seconds, we are going to get 15 times 60, and that gives us 900 seconds, because we are going to leave our answer in meter per second, okay? And so we take our average swimming speed, which is distance over time, and distance is 500 meters, time is 900 seconds. That's 500 over 900, and this gives us 5 over 9 meter per second. Or writing this as a decimal number, it gives us 0.556 meter per second. Hope that is clear. We move on to question 4A III. The B part said Rashid continues to swim at the same rate. Calculate the time it takes Rashid to swim a total distance of 5 kilometers. Give your answer in hours and minutes. I want us to also bear in mind here that 5 kilometers is equivalent to 5,000 meters. You know, the standard conversion is 1,000 meters equals to 1 kilometer. So when you have 5 kilometers, it means 1,000 times 5, which is 5,000 meters. Okay, and so here we say that Rashid swims 18.75 length in 15 minutes. If you go to the table, you'll see that the number of length that Rashid swims is 18.75. okay, and then we say the length of we are told that the length of each pool is 25 meters. So the distance for Rashid is going to be 18.75 times 25. That is going to give us 468.75 meters in 15 minutes. All right, and so the speed, of course, you know, speed is distance over time. So it's going to be 468.75 divided by 15. That's the time taken to cover that distance. That is going to give us 31.25 meters per minute. Okay, so now the time to swim 5,000 meters. The 5,000 meters, like I said before, is the same as the 5 kilometers. So the time taken, of course, when you see the relationship between distance, time, and speed, is that time is distance over speed. So since we have speed that's at 1.25 meter per minute, and so the time is going to be distance, which is 5,000, equivalent to 5 kilometers, 5,000 over 31.25, and that gives us 160 minutes. We are asked to give our answer in hours and minutes. So what do we do to get this answer in hours and minutes? We are going to convert this 160 minutes to hours. We divide this by 60, okay, to be able to convert it, and that gives us 2 hours. Remember, you can get 120 out of 160, and you have a remainder of 40, so it's going to give us 2 hours 40 minutes. So that takes care of that question. We now conclude here that Rashid's time is 2 hours 40 minutes. We move on now to question number 4A IV. Right? It says Blaze swims for 1 hour. The number of length she swims decreases by 5% every 15 minutes. Calculate the number of length she swims in the final 15 minutes. What do we do here? We say the initial number of length in first 15 minutes is 20. If you look at the table, the initial number of length for Blaise is 20, all right, in the first 15 minutes. And then subsequently, every 15 minutes, it decreases by 5%. So we are going to calculate it in 4 stages. Why? Because in 1 hour, we have 4 15 minutes. In 1 hour, we have 4 15 minutes, because here we are told that Blaise swims for 1 hour. Okay, so that's why we have 15 minutes in 4 places. So we are going to calculate 4 stages, of this. And so we say the first stage is the one given in the table, which is 20. And then the second stage, that 20, we decrease it by 5%. Of course, if you're decreasing by 5%, you remove 5 from 100, and then that your multiplier will be 95%, which is the same as 0.95. So multiply 20 by 0.95, it gives us 19. The third stage, we are going to decrease 19 by 5%. That 19 times 0.95, that gives us 18.05. And then the final stage, which is the fourth stage, we multiply the 18.05 by 0.95, and that gives us 17.1475. Okay, so we write this answer to 3 significant figures as required. As when we have a floating decimal, we are required to write this to 3 significant figures, and that will give us 17.1. And so that takes care of the solution to question 4AIV. If it's not clear, you can replay this video again and again until this concept is clear. All right, so we proceed to the next part, which is 4B. 4B, we are told that another swimmer, Adam, swims 450 meters, correct, to the nearest 25 meters. This takes 10 minutes, correct, to the nearest minute. Calculate the minimum distance Adam swims in 1 hour at this rate. So we are going to get this limit. Of course, first we look at the 25 meters. We'll break it into 2 because we need upper and the lower limit for the first distance, 450 meters, okay? And that will give us 12 point plus or minus 12.5. So for us to get the upper limit or the upper bound for 450, we are going to add 12.5, and that gives us 462.5. And for the lower limit or the lower bound, we're going to have 450 minus 12.5, and that gives us 437.5. Okay, so what do we do with all of this? We want to calculate the minimum distance that Adam swims in 1 hour. Okay, so we say the limit for 10 minutes. Of course, we're going to look at limit for 10 minutes is because we are told that it's to the nearest minute. We divide by 1 by 2. We take this to mean to the nearest 1 minute. So we divide 1 by 2, and we get plus or minus 0.5. And so we break these 10 minutes into upper limit or upper bound and lower bound, and this adding 0.5 gives us 10.5 as the upper bound, and removing 0.5 from 10 gives us 9.5 as the lower bound. All right, so the minimum distance in 1 hour, this is going to be taken as a rate distance per time, which is acting as speed, distance per time. So it's going to be 437.5 over the time is going to be 10.5. But then the question is, why are we using 437.5? Because we want to get the minimum. So the numerator is going to be the smaller of the two distances. It's going to be the smaller. So it's going to be the lower bound. And that's why we use 437.5. And then we also, if we want that fraction to also be small, we are going to divide by the bigger time. And the bigger time is 10.5. All right. And so why are we multiplying by 1 over 60? Because we are converting that minute to hour. If you are converting minute to hour, you just multiply by 1 over 60, or merely divide that time by 60. So this is going to give us 437.5 over 10.5 all times 60. And that gives us in 1 hour 2,500 meters. Okay, so that is the minimum distance that Adam swims in 1 hour. We move on to question number 5. We are told that a bus contains 3 blue pens and 5 red pens. Mia picks a pen from the bus at random. Find the probability that she picks a red pen. So here we get the number of pens. Okay, 3 blue and 5 red, giving us a total of 8 pens. And so she picks a pen at random. We want to find the probability that it's a red pen. Out of the 8 pens, we have 5 red. So 5 out of 8, that will give us the fraction that we need, or the probability. All right. So let's now go to the next question. Here we have to complete the tree diagram. And then we'll use that to do the I. So the I part, we want to complete the tree diagram. The blue, we have 3/8 for blue, and then remember 5/8 for red. Since this is done with replacement, even though it's not mentioned, so as it's not mentioned, it's taken to be with replacement. So the next, picking the next, the second one also is going to be 3/8 because it's returned back, and then if it's red that comes second, is 5/8. If the red is first and blue is second, we have 5/8, 3/8 for blue, and then we have 5/8 for red. So we've been able to complete this. And then the B part says find the probability that Mia picks 2 pens that have the same color. What does it mean? So it's either red, or blue. Okay, if it is red, that the first is red and the second is red, 5/8 times 5/8, or the first is blue, 3/8, and the second is blue, 3/8. All together, it's going to give us 34/64. That's, you have 25/64 plus 9/64. That gives us 34/64. And when this thing is brought to the simplest form, we have 17/32. Now I want to look at 5C. It says Mia now picks 3 of the 8 pens in the box at random without replacement. Find the probability that she picks 2 blue pens and 1 red pen. So now without replacement, we are going to complete this diagram again, but this time around our fractions are going to differ from the previous one. So we have 3/8 for blue, and then we have 5/8 for red. If the second pen is blue after the first blue, then the number of blue will drop from 3 to 2, and the total will drop from 8 to 7. If the first is blue and the second is red, the number of blue will, the first is blue, now the second is red, so the number of red will remain intact, 5, but the total number of pen will reduce because the blue has been picked, so we have 5/7. And then if the first is red and the second is blue, we have 5/8 for red. If blue is the second, the blue is 3, but out of a total number of 7 pens, because 1 has been taken without replacement. So if the first is red and the second is red, that means we have 5/8 for red, and then the number of red will reduce from 5 to 4, and the total will reduce from 8 to 7. So we have 4/7. Now, additional pen is picked because 3 pens. So what we do here, we are going to look at the third pen, and so we insert all of this, okay, for the third pen, and we have blue, red, blue, red, blue, red, blue, red, okay. And so we are going to look at the expected outcome from this tree diagram. So let's look at all the possible outcome, or the expected outcome. It can be blue, 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 this tree that she picks can actually be blue, 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 even though we are told that it's going to be 2 blue and 1 red. But let's look at all possibilities. Okay, so this is one of the possibility, and then it can be we can have blue, blue, and red. Okay, we can have blue, red, blue. Very good. We can have blue, red, red. Yes, it's an outcome. We can have, again, we can have red, blue, blue. Yeah. We can have red, blue, red. Yes. And we can have red, red, blue. Yes. And finally, we can have red, red, red. So these are all possibilities, okay? But we are concentrating on 2 blue pen and 1 red pen. So look at the probability of picking 2 blue pen and 1 red pen. So from this expected outcome, where can we see 2 blue and 1 red? Those are the 3 places we can see that, okay? So that limits us to what she possibly might have picked. And so from here, if we are to pick any of these, okay, that blue, blue, red, blue, red, blue, red, blue, blue, okay. So the probability of picking, for example, if it's blue, blue, red, because we will have 2 blue and 1 red, it's going to be, for the first blue, it's going to be 3/8. If blue is picked again, the number of blue will drop to 2. The total will drop from 8 to 7 times, if the third is red, number of red is still 5, but the total number will now drop from 7 to 6. Okay, this happens in these 3 scenarios. Okay, so we multiply by 3. We multiply these entire fractions by 3, their product. The product of these 3 fractions we multiply by 3, and that gives us 90/336, which reduced to 15/56 in its simplest form. All right. We proceed to question number 6. If you are still finding value in this tutorial video and you are yet to hit the subscribe button, we urge you to do so. Click on the notification bell icon so that each time we produce a new video, you'll be among the first to receive it. Tell us something about this video in the comment section. Share this video, give us a like, give us a thumb up, so that the YouTube algorithm can send this video to as many students as possible. All right, so now we proceed to question number 6a. The diagram shows a field ABCD. A straight path AC goes across the field, and we can see that straight path. Here we are asked to show that AC equals 1028 meters, correct to the nearest meter. So here we are going to use the cosine rule. All right, we're going to use the cosine rule. For us to find the find AC, we will be concentrating on triangle ADC. Okay, so we're looking at that triangle ADC. When we are applying the cosine rule, we have 2 sides and 1 included angle. So we have AC squared equals 420 squared plus 830 squared minus 2. Into bracket 420 times 830 times cos 106. Okay, now when we multiply out, okay, then this is what we get, and cos 106 is going to give us a negative value, minus 0.2756. Okay, we get 865,300 when we multiply, when we take the square of 420, and then we take the square of 830 together. All right, so let's see what this gives us further. Okay, of course it turns to positive because we have minus 697,200 times minus 0.2756. that will produce a positive number. Okay, adding it together, we have this. Okay, we have 1,057,448.32, and so AC is going to be square root of that value, and that will give us 1,028.323. So writing this correct to the nearest meter will give us 1,028 meters as required. So we've been able to show that the length of the line AC measures 1,028 meters, correct to the nearest meter. Let's proceed to the next part, which is the B part. Here, we are required to find angle ACB, or to show that angle ACB is obtuse. That is, that angle ACB is bigger than 90 degrees. That's what makes it obtuse angle. So let's see how to get that, and then We are also asked to calculate angle ACB. Angle ACB is obtuse. Angle ACB is obtuse, that's it, bigger than 90. So let's find it. So in that triangle ACB, we use sine rule. Say sine C over 1,150, which is the line AB is directly facing angle C, is equal to sine 62, and the line that is directly opposite is line AC, and we calculated line AC as 1028.323. Remember, we are now using the approximated value. We are using the raw value so that we are not going to, get ourselves into random error or approximation error. So here, if we make sine C the subject, that gives us what we have: 1,150 times sine 62 over 1028.323. Okay, so sine C, if we multiply out, we have 0.9874. So we are going to take the arc sine to find the angle C. We take the arc sine of that value, and that gives us 80.89. Okay, now remember that if that is what it gives, sine of 80.89, if of course 80.89 lies in the first quadrant and sine of that angle is positive, there's also an angle that will give us the same value when we take the sine. Okay, that's the angle that is the supplementary angle to 80.89 is 180 minus 80.89 for us to get the supplementary angle. Okay, so if we write this to one decimal place, that's 80.9, and then to get the obtuse angle, we take the supplementary angle of that, which means we are going to subtract it from 180, and that gives us 99.1. all right, so angle ACB 99.1 degrees, and it's actually an obtuse angle because it's bigger than 90 degrees. All right, so we take the C part of question number 6. It says part of the field triangle ACD is sold for $41,500. Calculate the cost of 1 hectare of this part of the field to give your answer correct to the nearest dollar. And we are told that 1 hectare is equivalent to 10,000 square meters. So we say here area of triangle ACD, okay, is half AB sine theta, which is half. A is 420, B is 830, and then the sine of the included angle, which is 106 degrees. And that gives us, if we multiply out, we have 167,547.9136 square meters. Okay. And now we are converting this to liters. We will divide by 10,000 because 1 liter is 10,000 square meters. Okay. So when we divide by 10,000, it gives us 16.75479,136 hectares. All right. Now we told that this entire hectare, because if you look at this, we are told that we are told that this is sold for $41,500. All right. Part of the field, that's triangle ACD, triangle ACD, the entire area. When you see that portion of the field, so we are talking about the entire area of that field sold for this. Okay, right. So what will be the cost of 1 hectare? Because that's what we are looking for. If the entire area is sold for $41,500, so for us to get the cost of 1 hectare, we are going to divide by that value, 16.75479,136. When we do so, we get 1 hectare to be 41,500 divided by 16.75479,136, and that gives us 2,476.90. But we are asked to write our value, the dollar, to the nearest dollar. The value, the currency that we get, we'll write it to the nearest dollar. So It means we are going to write to the nearest whole number, and that gives us $2,477. All right. Okay, so this is how far we can go in this tutorial. So we've been able to cover volume 2, and volume 2 takes care of questions number 3 to number 6. Hope you understood all the explanation. In our last volume, which is volume 3, we are going to look at question number 7 to question number 10. If you are part of us and up to this level you've stuck with us, we thank you very much for being there. And if you are yet to subscribe, we encourage you to hit the subscribe button, click on the notification bell icon so that each time we drop a new video, you'll be among the first to be notified. Go to the comment section, tell us your mind about this video. Like this video, share this video. We encourage you to be around next time we will bring up solution to questions 7 to 10 in volume 3. This is Math Minders Academy saying goodbye for now.
Just you and me lost in the